Okay, the next topic is standard basis vector. So we are interested in two special unit vectors. Vector I is horizontal unit vector. So let me use color. So I is horizontal unit vector and J is vertical unit vector. And of course, their coordinates are 1, 0 and 0, 1. So the reason we care standard basis vector I and J is that every vector can be expressed as combination of those two vectors. So for example, say a vector has coordinate 4, 3. And you can express this in terms of I and J. Well, you can quickly check that the addition of two vectors, 4, 0, 0, 3, will give you this vector 4, 3. And the first vector is multiple of this horizontal vector, 4 times I. And then the second vector is multiple of vertical vector J. That's it. So every vector can be written, this vector can be written as combination of I and J. So if you, this is nothing surprising. The first component is here, second component is here. So every vector, say component x and y, so your vector has a coordinate x and y, then you can express this vector as combination of I and j, xi, yj. So in this sense, the previous observation can be expressed in terms of I and j, horizontal and vertical component. So observation 2 says that, well, we can express vector as magnitude times cosine theta and sine theta. So vector A was magnitude of A, and then cosine theta, sine theta. So we can express this vector in terms of I and j. So this is A times horizontal component I, and then A times vertical component So we are using the previous line. So whenever you have your vector has coordinate x, y, this is xi plus yj. So x component times I, y component times j. Good. So in this sense, we call the first part horizontal component. The horizontal component is this part, A cosine theta. And then the remaining part will give you a vertical component. Vertical component is the second part, A times sine theta.